Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this second lecture of module 2 on water rock interaction or rock water interaction. In previous lectures we have discussed about water, its classification and a very brief description of water rock interaction to establish a fundamental platform at introductory level. Now in this lecture we are going to extend our discussion on surface water and subsurface water, particularly water accumulated in rivers and groundwater. So friends, in this lecture we are going to discuss about surface, subsurface water and their interaction with geoground. In this lecture we are going to cover about introduction as concept of water rock interaction or rock water interaction, type of water rock interaction, distribution of water on surface and subsurface, categorization of surface water and groundwater, and different types of rock strata and soil layer as per requirement, and then summarize in very brief about the water rock interaction, which we will elaborate in our future classes. This class is to develop fundamental foundation for our future class. Friends, as you know, the interaction of water with rock or constituents of rock and rock strata determines the change in rocks or rock strata due to change in their constituents, texture and chemical composition on one hand. On another hand, such interaction result substantial change in characteristic of both surface water and groundwater. For example, number of hydrothermal features, hydrothermal ore deposit concerned to geology and geothermal field are closely related to the consequence of the water rock interaction at high temperature. This concept we will utilize in our future classes. So interaction of water rock or rock water at high temperature. Friends, in pure geological interest, we are playing on the exposed lower crustal and mantle rock frequently exhibit features that resulted from the interaction of the rock with supracritical aqueous water under extremely high pressure and pressure condition that is concerned with different branches of geology. So we are not going to interact for particular this course. It is crucial to realize how water and rock is going to interact in field of geothermal energy, nuclear waste repository and high temperature engineering geology and hydrology as recent advances in field of engineering geology. If we are going to see here, this rock strata or rock body are made up of soil or rock strata. When this body is going to interact with water, then there is two side of changes. One side the water is going to change the physical features of this ground, and the component released from this rock or the soil or geoground is going to mix in water and going to change the feature of water. So on one hand, this interaction is resulting changes in rock or soil or geomaterial. On another hand, going to change in this interacting medium. So both components are going to show changes in their characteristic, both physical and chemical. Before discussing all these aspects, it is important to know about the concept of water and distribution of water through our earth crust. If we are going to recognize here the lower part of the crust, that is oceanic crust, and then the upper part, that is the continental crust, where we are here surfacial part, we are going to see about the loose deposit, that is sediments or soil. The water coming through precipitation from the cloud on this surface of the earth, upper portion of the crust, some of the water is going to flow following the gradient rule, and some of the water under low temperature condition going to freeze in form of snow or ice. After melting of the snow as well as addition of this precipitated water is going to move from the source zone, that is a provenance zone or source zone, and towards the lower gradient on surface. Some water is going to join and form a water body confined within the boundary of the rocks or geoground, recognized as a river. Some of the water is a field under this depression, recognized as a lake, and some of the water partially filled by this fresh running water and partially filled by the ocean due to tides and others. This portion having mixed type of water, fresh water plus salty water, salt water, and this mixture of the fresh water and salt water recognized as brackish water. So the depression filled by the brackish water is recognized as estuary. This estuary is located at the mouth of the river. If we are going to see, we have already discussed this young and youth stage, mature stage, and old stage. Some of the water from this running water is going to filter inside the subsurface through cracks, fractures, and filled in pores or filled in crack networks or fracture network present in subsurface rock, and get saturated through the seepage water and percolating water. This zone saturated with water is recognized as groundwater. In case of soil, similarly, this running water or precipitation water, surface water is going to fill the pores of the soil or rock. If this groundwater body is overlain by a competent impervious zone, then this type of groundwater is recognized as confined groundwater. And when there is no cap, no overlying impervious rock, then this type of groundwater is known as unconfined groundwater. The water holding formations is recognized as aquifer. We will discuss. So this zone is unconfined aquifer, and this zone is recognized as confined aquifer. The unconfined aquifer, here this level is representing the water table. Water table is the surface balancing this atmospheric pressure and this hydrostatic pressure due to saturation of water in this zone. Above this there is a capillary action, so we are recognizing as capillary zone. Above this we have aeration zone, so we are recognizing aeration zone. Then we have some temporary zone of water lying close to the surface is a soil feeding zone or soil root zone, and this by different names. This water is available for the crops and plants and other for their progressive growth. Then some of the water moving in rivers responsible to interact with rock or with soil during flow or during impoundment. As we have already discussed, there is both side interaction. This host strata is going to receive some changes, and this medium water is also going to receive some changes. First, as we have already discussed, some of the water is in solid form, ice or snow. When the snow, due to change in temperature condition and change in state due to availability of some water at the interface, and with change in temperature they started moving from its own position toward the downside following gravitational force or under gravitational force. Due to suppose movement of this, here I try to show with the help of this cartoon. This is the ice mass and this is the rock strata. When this water is going to interact with this, then some of the water freeze under this. Fractures are level in this rock filled by water, and due to change in temperature condition, freeze condition, low temperature, the water inside this fracture is going to freeze in form of snow and ice. When this body is going to move downside, are three conditions we are going to recognize. First, increment in volume of ice. Second, reduction in volume of ice. And third, movement of ice. If we are considering here the increment in volume of ice, then this increment is going to create some stress on this strata and going to make the changes on this strata and make this strata in form of smaller fragments. When there is reduction in volume during the retreat of glacier, then what happens? This compressed zone come under decompression, and due to release of the stresses there is also formation of some discontinuities. Here we are not going to discuss in detail, only elementary level, and also responsible for fragmentation of this underlying strata. Third point, when this ice is going to move from one point A to point B, then the frictional resistance acting between this body A and body B of rock is going to create lot of changes on the superficial part or shallow level part of this rock strata. In this way, the solid water and rock interaction or soil interaction is going to change the physical features of this underlying rock, as well as the changes due to drag, the changes in the overlying water, solid water body. Friends, this zone is also going to interact. This zone is also going to interact. The rock is going to interact in case of the groundwater, in case of the surface water. The surface water present in lake, are present in estuaries, are present in ocean, are present in river or subsurface. In all states, all locations, the water present in any depression is going to interact with the host geoground. Here you can see this solid water in form of ice is showing this movement toward the downside and going to scratch or release some fragments from the superficial part of this supporting strata. As far as the water is concerned, we have discussed different type of water. Previously, you know well, rainwater, surface water, river water, ponds water, lake water, estuary water, ocean water. These are on surface, and then the groundwater, subsurface, then the water present in plant surface, then industrial, domestic and other. So we are not going to discuss these things. We have already discussed surface water, particularly river and particularly groundwater. We are going to elaborate in big manner, and others water we will discuss time to time in our future classes. If we are going to see the water, we can categorize the water as a surface water and subsurface water. The surface water, water flowing on the surface of the crust, and good example water in river, lakes, ocean, estuaries, etc. Subsurface water, we are having some water of the geological nature, geological importance, some water present in rock, subsurface as a groundwater, and some water present in form of the moisture and some water in form of the capillary. So here we are going to discuss only surface water and groundwater. And friends, as you know, groundwater exits subsurface to the earth due to filtration of surface water through different conduits in form of fracture, in form of interconnected pores, or in form of different network of cracks. If we are going to see in view of the dynamics of the water, we can say that the running water and then semi-running water or semi-static water, then not fully, it is a pseudo-static state, pseudo-static water. We can say that the dynamic water means present in dynamic state, dynamic water representing flow. Then static water not showing any flow. Semi-dynamic water partially showing some flow time to time and partially not showing any flow. Then some of the water we are here discussing with respect to the change in position. Although minor fluctuations are always available in case of estuaries, in case of lake, or in case of ponds. Then groundwater, it is semi-static in nature, sometimes become dynamic and sometimes become static. So one of excellent example of the dynamic water we are going to discuss about the river. River is a body of flowing water confined within defined lateral boundaries which we are recognizing as bank, and following the decreasing gradient under the influence of gravity. A flowing body of water, if smaller in nature, it is recognized as a stream or creek or rivulets or brook, but standard form of the big moving dynamic water body confined within the boundary is recognized as a river. If we are going to see, although you know well, if we are going to see river initiated from the provenance where the water begins its flow, this provenance region we are recognizing as headwater. This headwater fed by rainfall or snowmelt, then some of the water may filter down in form of the groundwater. When the level of groundwater exceeds its natural condition, then this groundwater also sometimes partially going to feed this river as a source. If we are going to see the route of the river may passes through varieties of lithologies and varieties of geoground, consisting of different type of rock strata, different type of soil materials, mix of sediments, etc. At the end, that is known as mouth, water enters in large body of the water, that is ocean or big lake. Generally, we are preferring to explain this ocean. When the ocean water mixed with this river water in some depression nearby the mouth, then it is recognized as estuary. If we are going to see the water rock interaction, as we have already discussed in our previous discussion, due to rock water interaction or water rock interaction, there is two kinds of changes. One is a physical, another is chemical. And these physical and chemical changes not only in rock but also in water. So both sides interaction means there is a changes in both sides, not one side. Here you can see the view. This region is a headwater region, and this is the root region, and this is the mouth region. Here we are getting some oceanic body and others. So we have already discussed. If we are going to see about the processes involved in rock water interaction or in geological work of river, in another way we have taken this concept from the different processes, that is the erosion, transportation and deposition. Erosion means the displacement of the material through water from one point to another point, from the provenance side toward the mouth side. The displacement and the carrying behavior is known as transportation. The travel of material through water from one point to another point carrying by the water is recognized as transportation, and then accumulation of material at suitable place is recognized as deposition. The erosion in river mainly following attempts under abrasion, under attrition, under hydraulic action and solution. The abrasion is nothing. Abrasion is simply the release of constituent. This is suppose rock, and water is going to enter, water is flowing here. Then the constituent present in rock is going to release due to forces of drag caused by flow of water. So some of the constituents started releasing from this, abrating from this and coming along with the flow of water. So on one side, here the change in physical features of this zone, and another side this water which was earlier fresh in nature, now containing number of grains released from this rock. So there is a change in load. The load condition at this point A is a far different than this point B after interaction. Attrition is a very simple phenomena where here I try to show with help of this diagram, this cartoon. This is the flow of water toward the downside. Here this flow of water is going to carry this type of boulders at different points. Then what happens here? This boulder is going to collide with another. A boulder is going to collide with B boulder. Due to collision or collision induced, there is a development of some discontinuities in both. And these discontinuities is responsible for reducing the corners of these gravels or rocks on one side, on another side going to reduce the size of this type of boulders, and this type of boulders coming in form of number of small pieces, and that small pieces is going to move further down along with the flow of water. Third is the hydraulic action. Hydraulic action is a very simple. Hydraulic action is the action of water on ground. So thrust caused by flowing water due to shear stress acting between this interface of rock and the surface of flowing water is represented by the hydraulic action, and this hydraulic action going to release or cause release of some of the constituents, some of the minerals, some of the part of rock due to impact of this dragging. Next is solution. Solution is simply dissolution and deterioration of rock through solution action, and the material dissolved in water. So there is a change in pH of the water after interaction due to solution. Suppose before interaction at point A the pH was different, and after interaction when some of the mineral constituents going to mix in form of solution, then there is a change in pH. So the quality of water depends on the minerals present in the root zone as well as host zone. If we are going to see the transportation of material through river channel, here river channel, this is the bank, the water is flowing suppose in this way, then there is transportation through sliding of the bigger constituent close to the bottom of channel, through sliding and through rolling. When this, here I try to show with help of this cartoon, when this, suppose assume this boulder or gravel is started moving, then due to movement of this boulder is started moving from this point to this point, then due to movement what happens, the drag or frictional force acting between the surface of this bottom surface of the river and surface of this moving is going to release physically some of the constituent of this bed as well as this gravel also. The material then mixed in water in form of the finer components, sand size or silt size, and going to move downside. So rolling, sliding, these are bouncing, partially bouncing, not more. So representing the traction. So traction during transportation, traction is also a wave related to interaction of the water rock. In case of saltation in between here, I try to show, this is the water body, the flow in this direction. Then what happens? Some of the materials started moving through change in state. This material sometimes located at position A, sometimes located at position B, sometimes located at position C, sometimes located at position D or E, depending on the energy condition of the flow. When this flow is more, then it started lifting, and when it started lifting, then going to collide with another component present in way. Due to collision of this type of components, there is a reduction, breaking of both the component and reduction in size of the sediments. In this way, the sediments load is going to move from one point to another point induced by water rock interaction. This process is known as saltation. And the finer material which present in water is also moving in form of suspension, very fine material, silt size, clay size, carrying on the rock. During this movement, still there is some minor level of collision, not more. So, as we have already discussed, the traction, large boulders and rocks are rolled along the riverbed or slide along the riverbed, releasing some of the constituent of bed as well as boulders. Saltation, the small pebbles or sand size or stone is going to bounce along the river flow and going to result reduction in their sizes and release of some part of the river bed. Then suspension, we have already discussed, finer material is going to flow. Next aspect we are going to discuss about the rock water interaction in groundwater. First, what is the groundwater? So groundwater in brief we have discussed, but the groundwater is an important natural resource for our purpose, for drinking purpose, irrigation purpose and others. And this groundwater is nothing, it is the surface water infiltration into ground, move down until it requires impervious stratum. This impervious stratum is responsible for allowing the accumulation of water, and the zone later on with respect to time become saturated, and the saturated body is recognized as groundwater body, and groundwater body we are technically recognizing as aquifer. If we are going to see the groundwater body generally located in porous and porous sedimentary or porous igneous or porous metamorphic rocks, or sediment layer or soil mass or soil layer. The porous rock and rock strata or sediments layer saturated with groundwater is known as aquifer. Or any geological or any formation or any geoground saturated with water having some impervious bottom layer is recognized as aquifer. It may be covered by the impervious layer on top side and bottom side both, then it is recognized as confined aquifer. And if the upper layer is not present, not impervious in nature, open, then it is unconfined, but naturally. So the number of aquifers located in Indo-Gangetic plain area is mainly unconfined aquifer. However, the hilly terrains is rich in confined aquifer. The confined aquifer may change in unconfined aquifer with respect to time, depending on the due to water rock interaction or in form of erosion of strata. If we are going to see the geological formation or geoground from water transmitting and holding property of geoground, then we can divide the whole geoground from the water accumulation and transmission or the conducting point of view, aquifer, then equitard, equiclude and equifluge. Very simple. Aquifer have ability to transmit water, to hold water. and provide sufficient water in interest of society and humans and animals and plants. However, in case of equitard, very limited, it is a partially permeable nature and a saturated formation, but it not permits the water through its sufficient quantity for proper utilization. Therefore, this type of situation is not suitable to get the permanent water for drinking purpose or for agriculture purpose in sufficient quantity. Good example, if the ground is made up of sandy clay layers, then the clay is actually showing pores and sandy part is also showing pore. The pores present in sands are interconnected and able to permit the flow of water. However, the presence of clay is going to retard the flow. Therefore, the equitard is insufficient from availability of the groundwater. Then equiclude the similar way, but this equiclude is slightly different because here sandy material is present and equiclude belongs to clay material. It has capacity to store large amount of water, but the stored water cannot move from one point to another point due to impervious nature of this ground regarding this flow of water. That is, if the geoground is made up of clay layer, then we are recognizing as equifluid. And equifluid not allowing accumulation of water and not transferring. So an impervious geoground which is neither porous nor permeable and not allowing storage of water or transmit water. This type of ground we are generally recognizing in granitic ground, granitic terrain. Terrain or ground made up of crystalline granitic rock. Here if you see, this zone is equifluid, not going to allow any water. This zone, due to formation of fracture and others, it is suitable to allow the accumulation of the water, and equiclude is partially close to the equifluid, not allowing to transmit any water, only provide the space for the accumulation of water. So this part is also act as a seal, this part is also act as a seal. This type of zone is recognized as confined aquifer. When this equiclude or equifluid side not lying above, for example this case, this is known as aquifer. This is unconfined. Unconfined upper level of water is recognized by the water table. And this upper level of water table is not available in case of the confined aquifer because the water present in confined aquifer is under pressure, and this pressure is far more than the pressure, atmospheric pressure. Therefore, the water raised above the surface and come in form of springs. This upper level where this going to balance with this atmospheric pressure is recognized as piezometric surface. The recharge of this confined aquifer when this permeable zone is exposed to the surface and allowing the percolation or ingress of water inside, then this type of confined aquifer we are going to get when this impervious zone lying over above and below. So this is one view about this. If we are going to see here, water present in pores, cracks, fractures and others, and going to interact in this host zone as well as nearby zone overlying and underlying. Due to interaction of this water present in pores or cracks, going to interact and change in physical and chemical characteristic of water as well as host rock. So in this way, the rock water interaction is going to influence both confined as well as unconfined, equifuged layer also, equitard layer also, and equifer layer also. But the interaction resulted product depends on first nature of rock, nature of rocks here means about the mineral constituents, about the chemical composition, and about the texture. When we are going to see about the water rock interaction, this water rock interaction includes primarily three types of reaction. One is adsorption, another is dissolution, and another is a precipitation. In simple way, we can say that due to rock water interaction or water rock interaction, some of the constituents observed on the constituents of rock. The sum of the component of water absorbed in constituents of rock like minerals, and dissolved mineral, the dissolved material enter in form of solution in water, and this dissolved material at suitable condition going to precipitate and change the state of water as well as providing some new deposit. For example, one good example we have, due to water rock interaction in way of time, formation of conker in river. We have number of example of conker deposit in Yamuna river, in Ganga river at different localities, nearby Varanasi, nearby Allahabad, nearby Haridwar and others. This conker deposit, when this water is going to dissolve the carbonate from the source and going to precipitate in downstream side, then it is a good example chemical interaction about the water rock interaction. So this in brief we have already discussed about the absorptions, dissolution and precipitation, which we will extend our discussion in our future topics where we require discussion about the water rock interaction indirectly in very elaborate manner. So we can say that in summary, the groundwater as well as surface water also is a result of several geochemical processes that depends on the natural environment and human perturbation also, and this way we are going to pollute this area concerned to the water and others. That is another aspect. Here the chemical attribute of groundwater principally function of the mineral composition of the host, either present in root zone, either present in host zone in case of groundwater, during the movement or during the stagnant phase, or during the interaction with other type of water. In view of the interaction, if we are going to see the groundwater, we are going to classify based on the chemical constituents. We can say that it is the CaMgCO3 or CaCl2, NaSCO3, NaCl, CaSO4 and NaSO4 are important type of groundwater type found throughout the world, not in general, but it is due to rock water interaction. Engineering geological applications, we are more concerned about the engineering geological. As we know, there is a change in physical and chemical state of mineral constituent as well as rock, which are going to deteriorate the strength response of the rock, which will create lot of problem during our engineering geological applications. This concept I have prepared from different papers and other different books and others, but for your elementary concept you can contact your Bhutkari and Lama Katsuyama book, very interesting book regarding the rock mechanics, and then the obvious some engineering geological books, some geological book written by these authors, Bell, Kashualu, Waltham, and I have taken more material from this site, you can see. In conclusion, we can say that the water-rock interaction is significantly affecting both the running water, ocean water, estuaries, all estuaries, lake, groundwater. And there is a distinct change in the host geoground and the water due to water-rock interaction. The chemical composition of water is the result of water-rock interaction in surface water as well as in groundwater. Therefore, the water-rock or rock-water interaction is also effective in cold region and higher temperature region and useful for geothermal energy extraction, nuclear waste disposal, and precaution through the mitigation measure of the glaciers or avalanches in cold region. Dear friends, in this class we have discussed about concept of water rock interaction and rock water interaction concerned to the surface water and groundwater. The product caused by rock water interaction or water rock interaction depends on the nature of rock, particularly mineral composition, texture and structure, as well as resident time of water present for the interaction. Thank you.